Students, we are discussing our 7th unit of chemistry, that is the equilibrium. In our last lecture, we have discussed the topic of law of mass action and law of chemical equilibrium. And our today's topic of discussion is relationship between Kp and Kc. Before starting this topic, once we see some points regarding the topic of law of chemical equilibrium. In our last lecture, we have discussed up to the this expression, that equilibrium constant in terms of molar concentration, how we can write for this general reaction. Clear? And note, if the chemical reaction is in the gaseous phase, that is the reactants and products are all gases in nature, then we can also consider their partial pressures instead of their molar concentrations. Under the conditions, the equilibrium constant is denoted as Kp. Kp represents the equilibrium constant when partial pressures of the species are given. For this general reaction, where A and B reactants react to give products C and D, how I can write the expression for rate of chemical reaction in terms of chemical equilibrium constant. Clear? We have to write in terms of partial pressure the value of equilibrium constant. So here you can see I have written Kp is equals to Pc raised to its stoichiometric coefficient C, and then partial pressure of product D raised to its stoichiometric coefficients, and then to the partial pressure of reactant A raised to its stoichiometric coefficient, and then to the partial pressure of reactant B raised to its stoichiometric coefficients. So here Pa, Pb, Pc and Pd are the partial pressures of the species A, B, C and D. A and B are the reactants and C and D are the products. Thus, we can say Kc is the equilibrium constant when molar concentrations of the species are given, and Kp is the equilibrium constant when partial pressures of the species are given. Clear? Always keep in mind, when there is the molar concentration, we have to use equilibrium constant Kc, and if partial pressures are given, we have to use Kp as equilibrium constant. Means if the reaction is given in the gaseous phase for both reactants and products. Clear? And now move to the next topic, relationship between Kp and Kc. So we can see this relation as that is the relation between Kp and Kc. We have to consider a general reaction for this reaction. We have to go according to the law of chemical equilibrium when we are taking its molar concentration and its partial pressure. Clear? We are considering that this is a general reaction that is taking place in the gaseous phase and also in a state of equilibrium. Clear? Reaction occurs in gaseous phase and in state of equilibrium. Clear? I can write at equilibrium. So now how I can write the expression for equilibrium constant in terms of molar concentration, that is Kc will be equals to concentration of product C raised to its stoichiometric coefficients to the concentration of product D raised to its stoichiometric coefficient, and then product of concentration of A and B raised to its stoichiometric coefficients. And for Kp means I am considering the equilibrium constant in terms of partial pressure. I have written Pc raised to its stoichiometric coefficients, then P D raised to its stoichiometric coefficients, then Pa, and then Pb raised to its stoichiometric coefficients, where Pc, Pd, Pa and Pb are the partial pressures of the C, D, A and B. Clear? Now, according to the ideal gas equation, if the gas is ideal in nature, I can say for ideal gas, I can apply ideal gas equation PV equals to nRT, where N upon V will be equals to P upon RT. Clear? So now, but N upon V represents N upon V, as you have learnt in your previous classes, especially in 9th class. N upon V, that is number of moles per unit volume. It will going to represents the C, that is the concentration. Clear? So therefore, if N upon V equals to C, I can substitute the value of C in above equation. Here I will get C equals to P upon RT. Clear? So in equilibrium expression involving molar concentration, that this is of the species, the molar concentrations can be expressed in terms of partial pressures as follows. Clear? I can write it like Kc will be equals to Pc upon RT raised to power C, that is P D upon RT raised to power D, Pa upon RT raised to power A, and then P B upon RT raised to power B, where here I have substituted the value for N upon V, or you can say C. For C I have substituted the value, that is the P upon RT. Clear? Now I can take the partial pressure terms common. From here P A and then P B raised to power V, then I will get 1 upon RT raised to power C into 1 by RT raised to power D upon 1 by RT raised to power 1 by RT raised to power B. Clear? So here I have taken the partial pressures common, and now I can go for addition and subtraction of these denominators. As you have known, when similar terms are in division, we have to take the subtraction, and when similar terms are in multiplication, we have to do its additions. So I can rewrite this equation as to this equation. I can write 1 by RT. For same terms in multiplication, I have to do addition C plus D, and for in division we have to do subtraction. These both will be added and subtracted from the numerator containing terms. Minus A plus B. Clear? Now, where we have already discussed that Kp is equals to the product of partial pressure of product C and D and to the partial pressure of the reactants A and B. Clear? So now I can substitute the value of this for this, that is I can write it as Kp. So then the new expression that I will get, that is I can rewrite Kp is to the 1 by RT raised to power C plus D minus A plus B. Clear? So to this I can write Kp 1 by RT. So I can write C plus D minus A plus B as del N, that is the difference between the gaseous products and the reactant moles. Clear? Note that C plus D minus A plus B is equals to del N. Clear? That is change in number of moles. I can say that this is the difference between the gaseous product and the reactant moles, del N. That is the difference between gaseous products and reactant moles. Clear? So now I can write the equation as Kc is equals to Kp 1 by RT del N. Clear? Or for ideal gas, if we are considering or writing the equilibrium constant, then I can rewrite it like Kp is equals to Kc, that is raised to power del Ng. Clear? Where Kp is equilibrium constant when partial pressures are considered and Kc is the equilibrium constant when molar concentrations are considered, and R is the gas constant and T is the temperature in the Kelvin scale. Clear? The units of Kc and Kp are always mole per liter and kilopascal I can use. Clear? So the partial pressures are normally taken in atmospheres and therefore the units of R I can use like R we have to use 0.082 liter atmosphere per Kelvin per mole. So this is your expression or relation between Kp and Kc. Clear? If any problem is there, then you can clear your doubts anytime. Thank you.